Welcome to today's session, XNT305, Enrich your .NET applications with AI capabilities. Before we get started, quick question, how many .NET developers are here? Awesome, great. So if you're .NET developers, if you have existing .NET applications, then we'll show how you can enrich them with AI capabilities using AWS services. And in this session, like through a series of demos, we also built like end-to-end intelligent document processing application. So you will not see just demos of different services. You will see like how to build end-to-end application with these services. I'm Alex.
I'm Prasad.
And I'm based in Stockholm, Sweden.
I'm based in London, UK.
And we both started our careers as .NET developers, and now we work at AWS with .NET on AWS. Let's get started.
Cool. So, our mission at AWS is to take the experience and expertise that we have gained over the years working on artificial intelligence and machine learning and put it in the hands of every developer. Said another way, we want to simplify machine learning. We want to make it easy for developers to build intelligent applications. But before we dive deep, a quick reminder on the importance of artificial intelligence and machine learning. According to IDC, by 2026, global spending on artificial intelligence will reach $300 billion, growing at 4.2 times faster than the average IT spend. And according to Deloitte, 94% of the business leaders say that AI is critical for their success. And what it means for developers like us is that developing applications with ML capabilities is a skill that we all should be possessing. Now, we at AWS think of AI ML in 3 layers, and we are democratizing every layer so that you and your teams can move faster in adopting AI ML. Starting at the bottom layer, this is for ML experts who are comfortable building, tuning, training, deploying machine learning models themselves, working on the framework and chip layer on the frameworks of their choice like MXNet, PyTorch, TensorFlow. Then at the middle, we have Amazon SageMaker. Amazon SageMaker removes complexity at every stage of the machine learning workflow. It makes it easy for developers like you and data scientists to build and deploy machine learning models at scale. Now, with a quick show of hands, tell me how many of you work on SageMaker or ML infra as .NET developers? No one, right? Exactly. And that's where AWS AI services comes into picture. It makes it easy for .NET developers to add intelligence into their applications using simple APIs. The pre-trained models provide ready intelligence that can be integrated into your applications and workflows. And then we also have generative AI, Amazon Bedrock. Not the focus of this session, but Amazon Bedrocks allow accessibility to all the foundational models using simple APIs. So that is also very interesting for .NET developers. So there are other sessions on Bedrock at reInvent that you should be focusing on too. In this session, we'll focus on the highlighted services. That is Amazon Translate, Comprehend, Amazon Textract, and Amazon Recognition. And we will build an end-to-end intelligent document processing system solving a real-life business use case. And we'll be doing it using AI coding companion, Amazon CodeWhisperer. We will not be writing the code. We will just be prompting it. Amazon CodeWhisperer would be writing most of the code, as Alex will be showing shortly in the first demo. Alex, over to you.
Thank you, Prashad. So there are multiple ways of how you can interact with AWS services. You can do everything manually using AWS console. You can use CLI, command line interface, or most probably as a developers, you will use software development kits or SDKs. And we have SDKs available for many languages, for Python, for JavaScript, for TypeScript, for .NET, obviously, we have it like for C#, and this week we announced support for Rust and Kotlin languages. But the interesting fact about AWS SDK for .NET that it was the first AWS SDK released back in 2008. before SDK for Python, before SDK for Java, before SDK for TypeScript. So it's quite interesting fact. And as you would expect, SDK is distributed using NuGet packages, and it gives you programmatic access to all AWS services, including AI services, which we will focus on today. Also, SDK, it hides all the complexity on how you interact with AWS services, because you don't need to think if you need to pass payload as an XML or as JSON. You don't need to think like how to pass parameters like in a header or in a payload body. You don't need to think how to sign your request. Like SDK does everything under the hood. So you write your C# code, express your intent, and SDK does the rest. And also, there is a very consistent coding pattern when you interact with AWS services using SDK. So first, you import relevant NuGet packages. Then you add relevant using statements of namespaces you are going to use. Then you instantiate the client object. And optionally, you pass parameters like region or credentials, or it can get it from configuration files. When you compose your request, so it's like typed C# class, you get all the help from your development environment, like IntelliSense, pass the required parameters, and call the operation on a service. You get the result back, and then you based on the business logic of your application, you display this result or pass it to further processing. And again, I want to repeat that SDK, it hides all the complexity on how you interact with AWS services, because you see only these C# classes. You don't see what type of payload is under the hood. Is it XML or JSON or whatever it could be in future? But let's zoom in a bit. So even though there is a consistent coding pattern, still you need to know, okay, like what service to call, what parameters to pass, what are required set of parameters, what are the best practices. So, how many of you struggle when you start using new API, like SDK? So, okay, you need to read documentation, or maybe you need to search internet for some examples, copy-paste stuff. So still, there is some work needs to be done. So what if there is a tool which can help you with this task? When you work with a new SDK, it can accelerate your developer productivity. And this is where Amazon CodeWhisperer comes into picture. So this is AI coding companion. It's trained on billions lines of code, both Amazon and also open source code. And it helps you to write the code in a secure way. You prompt your intent in English words like in your comments, and it will generate either line or full function code for you. Also, CodeWhisperer is a generic coding companion, but also it's fine-tuned for AWS SDK. So if you use CodeWhisperer with AWS SDK, it will provide code snippets based on all the best practices we have. How you use it? So it's available as an extension to your development environment, to Visual Studio Code, to JetBrains Rider, or either JetBrains development environments. And again, 2 days ago, we announced support for Visual Studio 2022. So it's part of Visual Studio Toolkit for Visual Studio 2022. And it's available for multiple programming languages. So there is only few listed here. So again, JavaScript, TypeScript, Python, Java, PHP, Go, and so on. And C#. This is today's topic. So let's quickly jump to a first demo, and I will show how you use it in a real scenario. And the scenario which we have now, my laptop went to sleep. So simple scenario we have, okay, I have some text, and I want to identify, okay, what is the language of this text? And if the language is not English, I want to translate it into English. Quite simple scenario. So let me switch to the demo. So first I will show the application, and I will show the code. So this is a sample application. It's written in .NET 8. This is the latest version, long-term support version of .NET. And here I have text, and it's text about Amazon Lambda in French. And what I want to do, I want to translate this text into English. First, I want to understand what language it is, and then I want to translate it. So I have this button, and that's it. That's all I have. So, and this is the placeholder for my function. So there is nothing here at the moment. And what I'm going to do, I'm write my intent. OK, I want to detect language first. Detect language. OK. And this is the suggestion from CodeWhisperer. OK, probably you need to use detect dominant language request class. OK, makes sense. And then it says, OK, and this is the text you want to translate. OK. Now, CodeWhisperer says again, now probably you need to call detect dominant language method, which is asynchronous, on the comprehend client. OK. And then you need to get the first language and display it. I'm just clicking tabs. Now it's interesting. It even suggests me, like in the comments, what I want to do next, translates. And this is exactly what I want to do. But translate text. OK. It says I need to create translate text request. I need to pass source language. And again, source language code is the language which we just detected in previous lines. I want to translate it into English. And this is the text I want to translate. And then I'm calling translate text method on a translate client and output in the response. So again, I just clicked tab multiple times. OK, let's run and see if this generated code actually works. OK, I'm getting my text. And I'm calling translate method. And you see the detected language is French, and the text is translated to English. And also, if you don't know that this text was translated from French into English, if you just read this English piece of text, I mean, it's very like natural sounding. So because like Amazon Translate under the hood using the neural machine learning translation engine. So it's not like statistical based like the translation services which we used before. So that's why it's really looks natural. So you won't understand that this is something translated from another language. OK, so this was the first demo. Over to you, Prashad, again.
Thanks, Alex. Or should I thank CodeWhisperer for writing the code?
No,
did not do anything.
I wrote comments and I clicked tab multiple times.
That's pretty much
so,
right. Like,
I mean,
it was
I did something.
Yeah, something. Agreed. But yes, Alex did show you how easy it is or how comprehend can be used to detect the languages. Comprehend has a lot more capabilities. It is not just about detecting language. It can detect entities. It can detect personally identifiable information. It can tell a sentiment whether it is a positive or a negative. It is able to extract key phases. It is able to classify the documents or organize your files based on a topic. And all these functionalities that Comprehend provides come under the umbrella of NLP tools, which is natural language processing tools. Now, there are a lot of natural language processing tools available open source for free, but with all of them, it comes with a cost. And cost is the ML development experience that developers would be needing. Now, developing models is not an easy task. It's a multi-step process. Starts with your data preparation. You need to know the kind of data you need to train your models. And if you're training the model from scratch, you need to collect thousands of files so that you're able to train it accurately. And you need to do it iteratively, selecting the right models, identifying the right algorithms, providing the right set of data, so that you are able to completely train and build the model. And even when the model is built and tuned and you're deploying it onto production, it needs to be continuously monitored and managed so that it stays relevant. Now, all of this is not required if you are using AWS AI services. The pre-trained model of AWS AI services provides ready intelligence. And on top of that, it also provides an easy-to-use API. If you're building your own models, then you need to create a wrapper around it and an API so that you can access it in your applications. But all of that is already done using the AWS AI services. And we have seen that, how easy it is to use using the Amazon Comprehend. But let's dive deep and see another demo to ensure that we understand fully how Comprehend is used. Alex.
Thank you, Prashad. So let's quickly do another demo. So as Prashad mentioned, Comprehend can not only detect language of a text, it can do multiple tasks. And now let's see how we can use Comprehend to detect entities inside the text. So again, I have my demo application, and I have sample text about Adam Selipsky, our CEO. What I want to do, I want to detect different entities inside this text. OK, so again, I have a placeholder for my method. And again, this method is empty, so I will use CodeWhisperer to generate code for me. And I'm writing my intent. Detect entities. OK, I need to use detect entities request. OK. And then I need to use the text, and I'm going to do it in English. OK, then I need to call detect entities asynchronous method, and then create a string builder, append the line, append another line, and then iterate through collection of responses. And then output result back. So you see that CodeWhisperer generated code, and this code could look like a bit weird. It's like, why would I use like string builder? Why would I use like append line with number of equal signs? Then why would I use like substring and so on and so on? So the thing is that Comprehend is not only using the base model which is trained on, CodeWhisperer is not only using the base model which is trained on, it also understands the context which I'm working in. And looks like inside of my file, I have like another method which detects personal identifiable information. And this is how this other method looks like. So in this other method, I used this string builder pattern. And what CodeWhisperer thinks, like, OK, looks like string builder is a thing in this organization. Looks like developers love string builder. OK, like, let me generate the code which mimics this coding style. So that's why the code generated by CodeWhisperer for my detect entities method, it looks like this, because it just mimics the code which someone wrote before. OK. Let me run it again. Let me copy the text. And detect entities. OK, looks like I need to recompile it. Let me run it again. So this is my text. OK, so this is the results coming from Comprehend. But OK, Adam Selipsky is a person with confidence over 99%. Amazon Web Services is an organization. AWS is an organization, also with confidence over 99%. And also we have multi-billion dollar is a quantity, 2021 it's a date. And then, yeah. And again, this is functionality which is provided by you by Comprehend, and then it's up to you as a developer how you use this information inside your applications. OK, this was the second demo. Over to you, Prashad.
Thanks, Alex. And thanks, CodeWhisperer.
Again, I did something. So.
Yes, you did. I'm not disagreeing. Now, we have seen how easy it is to use Amazon AI services, right, using simple APIs. So let's use that to build intelligent document processing, solving a real-life business use case. Right? Now, paperwork. Who loves paperwork? Oh, there is one person. Great. So yeah, in almost all the industries, right, and across all organizations, whether it is finance, medical, insurance, retail, all of them have paperwork, and most of these companies use manual document processing step. And that cannot scale, right? And that's where intelligent document processing comes into picture. Intelligent document processing is an industry term that is used to describe the extraction of the text and insights from within documents. And these documents can be structured, semi-structured, unstructured, and we'll see all of that through the demo using artificial intelligence and machine learning. Now, let me tell you my experience about revamping a remortgage platform of a bank. This was around 5 years ago when I was consulting for a bank in UK, and they had this remortgage platform built as a huge .NET monolithic application. And they had manual step at every stage of the workflow. Now, we as consultant had to modernize it, and we did modernize it. We split the monolithic to microservices, we streamlined the DevOps pipeline, but still many aspects of the document processing were still very manual. Now, knowing what I know about Amazon AI services, this is how I would solve that manual document processing step. Now, think of you are building a claims processing system for an insurance customer, right? And the claims processing has to go through multiple checkpoints before it can be decided whether or not the claim is accepted or rejected, the insurance company should be making a payout or not. Now, OCR, optical character recognition, plays an important role in automating those steps. If there is a document like claim form which is structured, OCR is able to extract all the information in an automated manner and then provide it to the business rules to make that decision. But there are other documents, supporting documents, which might be doctor handwritten notes on a discharge summary or a medical transcription. And that's where a manual review is required, and which becomes a bottleneck, a manual intervention, and it is not scalable. Now, if you're building the same using intelligent document processing system, where in most scenarios, your documents can be processed straight through, and the decision can be made. But there will be few scenarios, like for example, let's say you are processing a claim of $1 million. You would like a manual intervention to check that all the documents are in place or not. Or let's say in the previous steps of the document processing, the threshold is not meeting, like it is being processed with a low confidence score. Then you would need a manual intervention. But in most scenarios, the documents will be processed automatically. So it will not be a bottleneck. So let's start building an intelligent document processing pipeline. What you see on the screen is a high-level representation of that, which will be going through if you are building a claims processing system or any other real-life business use case like loan application or bank account opening. Most of this document processing would follow these kinds of steps. Starting from the left, data capture. This is where you'll aggregate all your files in a specific location in a secured manner. Then these files need to be identified and classified. What do I mean by classify? So let's say if you need to verify income, there are two kinds of documents, your pay slips and your bank account statements. Now, the data extraction on these two different documents would work separately. So they need to be routed to the specific data pipeline. So that's where classification comes into picture, and then they're routed to the right pipeline, and the data is extracted from that. And once the data is extracted, there might be an optional step of enrichment based on scenario to scenario. If, let's say, your documents have PII information, that needs to be masked. So that will be an enrichment of the data. And then the final step would be review and validation. That's where you can make a decision, have business rules in what scenarios you would like a manual intervention, and in what scenarios you will be confident enough for a straight-through processing for a business decision to be made. Now let's dive deep into each of this step. Starting from the left, data capture. Amazon S3 is where you will be able to store all your documents in a secure manner. Think of this as a centralized inbox for all your documents. And then these documents need to be identified and classified. And if you talk about specifically claims processing, right? So there would be multiple kinds of documents. Your claim form, your supporting documents can be invoices, discharge summary, medical transcription, identity documents. And these can be actually classified using the services Amazon Textract and Amazon Comprehend. Let's zoom in a bit more. Alex.
Yeah, so this is how we're going. This is what we're going to show in a demo in a few minutes. This is the document classification part of the whole IDP pipeline. So we have a bunch of documents, and these are the documents which we know. I mean, this is based on like our industry and our use case. Then we are going to use Amazon Textract to extract raw text data from these documents, because these documents are just images like PDFs or JPEGs and so on. Then we'll prepare a special document, so it's a CSV document which is required for Comprehend custom classifier. And CSV document with two columns, like one column is the document type and the second column is the raw text data. So we will train Amazon Comprehend custom classifier, and then we will deploy it to the real-time endpoint. So what we can do with this real-time endpoint, when the new documents come to our system, we call the endpoint and we get the information, okay, what type of document it is. And based on the type of a document, we will route it like to different processing pipeline. So, okay, like if it's invoice, probably we need to extract line items from this invoice. If it's a driver's license, probably we need to extract like information about, I don't know, who is this person, age, and so on. Again, if it's some medical documents, okay, it will be like another pipeline to process these documents. Okay, let's see it through the demo. So this is my application, which you already know, and this is the document classification stage of the IDP pipeline. So there are three things which we're going to do now. So first, we're going to prepare the training data, because we need to train our custom classifier on our specific documents which we have like in our industry. And then we'll create the classifier, create this real-time endpoint, and then using this endpoint, we can detect the type of documents. Let me switch to the code. So I will not use CodeWhisperer now, but I mean, I used CodeWhisperer a lot when I wrote this code. So first thing, there's some helper methods which I have. Just a second. Okay, so as I said, first method, we need to get raw text data from the documents we have. So I have this helper method, create get document lines, and it's using Textract to extract raw text data. So in a request, I'm saying, okay, I want to use the document which is located in the specific S3 bucket. Then I'm calling detect document text method. It will give me a list of the lines, and I'm just appending these lines into my favorite string builder. So as a result of this helper method, I get like all the text from a document in one long line. So second method is to actually create this CSV file which I need. So what I'm doing here, I'm just iterating through all the files in my S3 bucket, and each file, it has a prefix of a type of a document it is. So I'm iterating through all the files. Then based on the prefix, I'm creating this CSV file, putting the type of a document and the extracted raw text data from this file. And this, let me show how this file looks like. And I already did it because it will take like a long time to process all the documents. So I already created this file, already uploaded to my S3 bucket. So I'm using JetBrains Rider. I have AWS Toolkit installed, so I can go to my S3 bucket directly from inside my JetBrains Rider. So this is my S3 bucket, and I already uploaded this CSV file there. So just a second. OK, I have this file locally, so I will not download it. I will show it locally. OK, so this is the CSV file, which I said it has like 2 columns. One is the type of a document, and the second one is raw text. So we have some driving licenses, some passports, some insurance IDs, some CMS 1500 forms, and so on. So this is how a CSV file looks like. And then next step is to actually create a document classifier. So again, some preparation, and then I'm calling.
It finally opened up.
Yeah, my create doc. I'm looping through all the classifiers, if document classifier doesn't exist, I'm using create document classifier request. I'm saying, OK, this is multi-class classification because we have many types of documents, and this is my document classifier name. Then I need to give access to comprehend to my S3 bucket, so I already have IAM role created which gives access to comprehend to my S3 bucket. And then I'm saying, OK, I'm using the training document in comprehend CSV format, and this is the file in my S3 bucket. And then I'm creating a classifier. Again, classifier is already created because it takes quite a while to train it. So I already have it. And then once I have a classifier, I'm creating this real-time endpoint. So I'm deploying this classifier to real-time endpoint so that I can detect types of my documents using classifier which is trained again on my documents. Again, I'm just using create endpoint request and calling the create endpoint async. So with that, what I can do, I can choose a file. So this is my discharge summary, for example, and call detect document type method. And again, it says that this is discharge summary document with confidence over 99%. So if I switch back to the code, this is how my detection of a document type looks like. So there is a boilerplate code on how I download the image, but this is the actual call to the API. I call classify document request. I'm providing the document, my image, just as a byte array. And then I'm saying, OK, I'm using this classifier and some configuration. Then I'm calling classify document method. And as an output, I get the list of classes with confidence scores. So this is discharge summary with confidence 99%. And with very, very low confidence, probably it's this CMS 1500 form. OK, so this was the demo. Again, over to you,
Thanks, Alex. Now, the next step. Once you have classified the document, we need to route it to the right data pipeline so that the data can be extracted accurately. Now, your data can be a claim form, which is a structured document, and it will have a different data pipeline. It can be discharge summary or medical transcription with handwritten notes. It will be sent to a separate pipeline. And Amazon Textract can be used to get the data from these documents. Now, there might be scenarios where you don't even need to extract from the documents. Let's say it is your identity documents, like your passports or your driving license, which you want to use to verify the identity of a person. You can pass it directly to the Amazon recognition, and it will be able to automatically do that. But let's first dive deep into the Amazon Textract and see how the data extraction pipeline works. And then we'll come back to Amazon recognition to see how identity verification works. Alex.
Thank you, Prashant. So I already showed one feature of Amazon Textract, so how it can extract raw text data. And this is the data which we use to create this CSV file. But Textract can do much more than that. It can work with tables and forms. So when Textract works with tables, it preserves the structure of your document. So the results which you get with Textract, it will have like the same table structure. So you can access columns, you can access rows, you can get information about headers, and so on. And when Textract works with forms, again, instead of giving output as a raw text, it gives you output as a key-value pairs. So again, it's much more useful when you process the data to work with key-value pairs instead of just wall of text. But it can do even more. So what if I don't want to think about document structure at all? What if I only need to get information about like specific data point like in my document? And this is where Textract queries comes into play. So Textract queries, it's a AI feature of Amazon Textract. So it's a pre-trained model which allows you to ask questions in a plain English text and give a result back. So, for example, in the document which you see on the screen, so it's the insurance ID card, and I can ask a question, okay, what is the member name? And the Textract query will be give me an answer, okay, it's John Doe. So I don't need to know like the structure of this document. I don't need to know, how to parse it. I ask the question and give the answer back. So let's see how it works. Again, in a demo. So I have my insurance ID card. So first, if I use Textract just to extract the text from this card, this is the output I get. So basically like the wall of a text, just lines and words. But if I use like the same document, but use the forms feature of Textract, then I will get like same data back, but it will be structured as a key value pairs. So if I zoom in, okay, this is the member ID, this is the member ID value, this is the group number, pair ID, and this is the, this is the information I get back. Sorry, I cannot. This is the group number, PCP name, and so on. Okay, I cannot zoom back. Now let's see in the code how it looks like. So if I my pages and analyze document. So if I want to use this forms feature, so again, first it goes like just generic code on how I save a file, how I display file, but this is the method, analyze document request. I am providing the document and I'm saying, okay, I want to use feature type forms. Then I call analyze document method, get the result back, and then out of all results, I'm interested in key value pairs. So I'm interested the results are listed as a block types, and I'm interested in the block type key value set. And then I get the relations in this key value, so I'm just getting this key value pairs back. Also, Textract returns me the geometry of the answer. So all the bounding box. So on the screen, you see that there is a highlighted like red area. So this is again like the information which I get from Textract back. So again, if there is something with like low confidence, then I can see like where this comes from to do some validation. Okay, but as I said, Textract can do like even more. So we can just ask plain English text. So I can use the same document, my insurance ID card, and then I can ask the question, okay, what is the member name? So the answer is John Doe with confidence 99%. And this is the information where this value comes from. So again, if the confidence is low, this is probably I can put like into manual validation. And then you can see like visually, okay, where this answer comes from. But again, I don't need to think about the structure. I just ask a question in plain English. Again, from the code perspective, you will see the same coding pattern which you already used to. So I'm calling the I'm creating this analyze document request. But here I'm saying that I want to use feature called queries, and I'm providing the configuration for this queries feature. List of queries, and query is just a text. Okay, what my question in English. Also, I can ask multiple questions like in the same request. Here I'm just asking one question, but I can ask multiple and get the results back. And then again, I'm calling this analyze document method, and then getting the query result back. Okay, what is the answer and what is the confidence? Again, like few lines of code which can provide you with like powerful information on how you can extract information from a document. And one more example I want to show is how you deal with invoices. So again, like invoices is a very specific type of a document where you want to get information about line items, about the price, about like who is the vendor, and yeah, all the characteristics of a vendor. So here I have a insurance invoice, and I will show the code in a few minutes. So this is my insurance invoice. So it's information about hospital, information about patient, and some line items. And this is the information extracted by the Textract. Okay, so these are the line items with their prices, and this is the summary fields. So there is a lot of them, but you can see that there is a receiver address, like receiver name, vendor address, and also all the information about invoice itself, like, okay, what is the total, what is the tax, what is the subtotal, and so on. From code perspective, actually, it's a specific method on Textract which deals with invoices or with expenses. So there is a method called analyze expenses for this very specific use case. So I'm creating analyze expense request, and the only input I'm providing is the document which I want to analyze. Then I'm calling this analyze expense method, and it gives me output as a list of documents, and each document has a structure of line item groups. Each line item group can have line items because like invoices can have quite tree structure. And then for each line item, I'm just checking, okay, what is the price, what is the item. And also I'm getting all these summary fields, like vendor name, vendor address, email, and so on and so on. So again, this is pre-trained model in the Textract which deals specifically with expenses. So, and as you see, like this functionality can be achieved with, 10 lines of code. So like imagine you build this functionality yourself, like how long it would take.
And tell me honestly, like how much you did it and how much CodeWhisperer did it?
In this case, it was half-half, I think.
Okay.
So because it's a bit more complicated because I need to show the image, highlight the area, so it was art.
So that's it. It's a productivity booster tool, right? So it's going to help you as much as it can. Now, the next step. Now you'll see the pipeline even building even further, right? And we'll recap this when we'll reach the full pipeline again. But the next step here is enrichment. Now, as I said, it is an optional step, but there will be scenarios where you would like to enrich the data that has been extracted. And we talked about PII. Now, claim forms will definitely be having a PII information. That might have to be masked. Otherwise, what will happen is that people who might not be accessing the data would have access to the data. So to avoid that, you'll have to identify the PII information within the documents and mask them before sending it downstream, or whoever should not have access, you will not send that document there. Let's see through a demo how you can identify the PII information.
You can click yourself.
We'll do that.
Yeah. So next demo. As Prashad said, we want to identify personal identifiable information in the document, and then probably we're going to mask it, or probably based on what we detected, it will go like to different route in our document processing pipeline. But let's take the document as an example. So it's a discharge note summary. So this is sample text created by the doctor. And this is the personal identifiable information which was detected. Okay, this is a doctor name, person name, and also age. Actually, like 35, it's an age. Also, it's classified as personal identifiable information. So this is where it comes from. 35 years old. So it detected, okay, this is the age, actually, type of information. So how it works in the code. Again, you would see similar coding pattern which you already saw before. So here we are using two services in conjunction. So first we are using Textract to extract the raw text from this document, and then we are using comprehend to detect personal identifiable information. So for text extraction, same as before, detect document text request, get all the text, create a string builder, have text ready. And then we are calling detect PII entities request, providing the text as an input, English as a language, and then we call detect PII entities async method. We get list of entities back. We just enumerate these entities and output the type of entity and the confidence score. So again, this is the example of how you can use multiple services like in conjunction. So like not one service, but I don't know, multiple services. And this is how you build real like AI enriched applications, not by calling one service, but calling multiple services. Okay, so this was enrichment demo.
Cool. Now the last step here is that in a positive scenario, when I say positive scenario, when all the previous steps in the document processing are done at a high confidence, then you'll be able to send those documents downstream to make a business decision, whether accept or reject a claim. If not, that's where you can actually loop in for a manual review. If the previous document steps are of low confidence or does not meet the threshold that your business has set, for example, your business has set a threshold of 95%, and the data extraction by the Textract has shown a 80% confidence. That's where you can loop in a manual review. And we do have a service, Amazon A2I, Amazon Augmented AI, that helps you automate the human review process. Now, there can be other business rules, as we discussed, $1 million or more claims, right? Or it's customizable. You would be able to set those business rules and accordingly loop in humans for review. The same can be done for Amazon Recognition. Amazon Recognition, when verifies our identity, will be providing a confidence score. If it matches your threshold, then you would be able to pass it downstream to take a business decision. If not, you can ensure that a manual review of our identity document happens. Now, we'll dive deep a bit more into recognition, but this is the whole pipeline end-to-end with these steps. And at every step, you will have Amazon AI services that you can use to automate these processes. Now, combined or individually, each of these automated stages helps you to reduce the overall effort and the cost, improving the business outcomes of your document processing. But let's talk about recognition in a bit more detail. As you can see on the screen, Amazon Recognition provides a wide variety of features, enabling various use cases. It makes it really easy for developers to add intelligence like image analysis and video analysis into their application. You need to just provide your image or video or even live feed to the API, and it will be able to detect the entities. It will be able to enable other use cases. For example, it provides a highly accurate facial analysis and facial recognition system. So it enables use cases like people counting, celebrity recognition, public health use cases. So in a nutshell, Amazon Recognition is a managed AI services that provides multiple AI ML capabilities and provides a very strong set of face APIs, which enables the use case that we are focusing on today in this demo, that is identity verification. Let's zoom in a bit more.
Yeah.
Alex.
So this is how typical identity verification process would look like using Amazon Recognition. You have a document which user submitted, like passport or driving license. And when you want to maybe talk to this user over video, and you want to ensure that this is the same user whose document you have. So you need to check that this person is live on video, so it's not just you're talking not a screenshot. When you compare this video stream with your identity document that you have, maybe you search this video with list of documents which are frauded or something like this against your database. And when everything is correct, then you validate that this is the same user. And this is what we're going to do to see in the demo in a second. So again, let me switch to my demo, and then I will show the code. So I have an ID. So in Sweden, when you renew your driving license, actually the process looks like you go to photo booth, you take a picture of yourself, then there is a paper form, you attach picture to this paper form, send it to police, police receives it, scans this picture, and prints it on your driving license. So your picture on a driving license is copy of your copy of your copy, so the quality is not perfect, I would say. So this is the ID which I uploaded here. And then I have my screenshot from my camera. And I want to verify, the person who submitted this ID card, it's the same person. So this is my ID card, as I said, copy of a copy of a copy. And this is my selfie. And still, recognition says that, it's the same person with a confidence 99.9998%, nearly 100% confidence. Imagine the use case that, I submitted my ID card, but Prashad came to interview.
He's deliberately using a very bad picture of mine. He wants to show that he looks better.
The only one I have, sorry. Then it says, sorry, no matching faces. So, and if we look at the code, again, you will see same consistent pattern which you already saw before. I'm creating this compare faces request. I'm providing only two parameters, source image and target image. And I'm calling compare faces method on the recognition client. And if there are more than one face match, I'm just getting the face, and this face has a bounding box which I'm just displaying on the picture. And also it has the information about the confidence, what is the similarity percentage. But again, few lines of code, and you get this powerful functionality. And again, if there are no matching faces, I am just saying no matching faces, which was the case with Prashad. But that's it. That was the last demo we had.
Thanks, Alex. And now we are reaching to the end of the session. So quick recap. So what we have seen today is that how easy it is for developers to add intelligence into their application without needing the ML skills. And I'll repeat that. Without needing ML skills, developer can add intelligence into their applications. We have seen that through the demo of Amazon Translate, Amazon Comprehend, Textract, and Recognition. And we have done most of the coding has been written by AI coding companion, Amazon CodeWhisperer. Now, for you to start, Amazon CodeWhisperer is a free-to-use for individual license. So it's individuals, it is free to use. So feel free to give it a try. The second link is the demo application, all the code snippets that Alex has shown in the live demo. It's all there in the GitHub, so you can clone it and try it on your own, the end-to-end document processing pipeline. And the third is explore all the AWS AI services. With that, thank you so much for attending. Please do fill the survey. It's really important for us to understand how we did and what we can do better.
Thank you.